Hello children. So today we are going to start a new chapter, that is quadratic equations. Okay, so you have done in class 10 also. Okay, so now it will be more advanced. Now let us see. Okay, so an equation of the form ax square plus bx plus c is equal to 0. Okay, where your a is not equal to 0, a, b, c are the real numbers. So such an equation is called a quadratic equation. Okay, so ax square plus bx plus c is equal to 0, where a is not equal to 0, a, b, c are the real numbers, is called a quadratic equation. And a quadratic equation has two roots. Okay, and it is given by the formula this minus b plus minus square root of b square minus 4ac by 2a. Okay, where b square minus 4ac is called discriminant, where b square minus 4ac is called discriminant. It is denoted by capital D or this small triangle. Okay, it is called delta, and this discriminant help us to decide the nature of the roots. Okay, this also you'll have done in class 10. So let us revise once. So here first is, if d is greater than equal to 0, then roots are going to be real. Okay, and if d is greater than 0 and d is a perfect square, then roots are going to be real, rational and unequal. If d is greater than 0 and d is not a perfect square, in that case your roots are going to be real, irrational and unequal, and they are going to be conjugate of each other. Okay, so suppose for this case where your d is greater than 0 and d is not a perfect square, and I get a root 1 plus root 3. Okay, then the other root will be 1 minus root 3. Okay, so that's why for this case the roots are conjugate of each other. Done. And if d is less than 0, then roots are imaginary. Okay, and in that case also roots are going to be conjugate of each other. Suppose one root is 3 minus 2i, then the other root is going to be 3 plus 2i. Okay, so let us see a few examples. Okay, and try to understand through graphs. Okay, so here let me take one quadratic equation. Okay, here you can see fx equal to 1x square minus 4x plus 7. Okay, so I'm going to change, in place of a I'm going to take 4. Okay, and in place of b I'm going to take minus 12, and in place of c I'm going to take 9. Okay, so here you can see that this is the graph, okay, of this quadratic equation 4x square minus 12x plus 9. Okay, here you can see that discriminant is coming 0. Okay, and you know that if discriminant is 0, okay, in that case roots are going to be real and equal. So here you can see that this graph touches the x-axis at only one place on x-axis. Okay, done. So that point is only the root. Okay, and it touches at only one place. Done. So that's why it has got equal root. Okay, that means the first root is also 1.5 and the other root is also 1.5. Okay, and this shape, okay, this shape is called parabola. This shape that you can see on your screen, this is only called parabola. Okay, and you should always remember that this ax square plus bx plus c, okay, it is a polynomial of degree 2, okay, and this is only called parabola, okay. Like for a straight line equation, general equation is ax plus by plus c is equal to 0, okay. So same way, general equation for a parabola is ax square plus bx plus c, okay. Since it is of degree 2, that's why we call it quadratic expression, okay. Otherwise it has got a specific name that is called parabola, okay. And this is the shape, okay. This is the shape, you can see this is the shape of the parabola, okay. And this, the vertex, this turning point, this point is called turning point, okay, from where it, see, it's coming from up, okay, and this point again from here it starts moving up. So this point is called turning point, okay, also known as vertex. Done. So what you see that this is a second degree polynomial, and it has got, and we call it by parabola. And when you plot this parabola, okay, you find that three things will, may happen. Either that parabola will intersect the x-axis at 2 points, okay, or at 1 point, or it may not intersect the x-axis anywhere, okay. Now if the parabola intersect the x-axis, okay, the point where it intersect, that is only called the roots, okay. That intercept on the x-axis is only called the roots, okay. Now if the parabola does not intersect the x-axis, okay, then that quadratic expression will have no real roots, okay. In fact, it will have complex roots, okay. So in this case you can see that this parabola 4x square minus 2x plus 9, or you can say the quadratic expression, okay, or quadratic function here, this, when you're plotting it, it touches the x-axis at 1 point, okay. So the point where it touches on the x-axis, okay, or the intercept that it makes on the x-axis, that intercept is only the root of this quadratic expression, okay. So 1.5, okay, for 1.5, when you replace x by 1.5, this expression becomes 0, okay. That's why that 1.5 is called root, okay. So root means those points, okay, those values of x for which the expression becomes 0, okay. So for this you can see it's only 1, that is 1.5, okay. The value of x is 1.5 for which this expression becomes 0. So that 1.5 is only the root, okay. And this is a parabola, and you can see it intersects the x-axis at 1 point. So that that intercept is 1.5. So 1.5 is the root of this, okay. Now here you can see that just now we discussed that I have not mentioned over here that if d is equal to 0, then it will have equal roots, okay. But anyway, you'll have you all know that in class 10 you'll have done it, okay. So when you're copying this note, in that case, please add that point, okay. In this, in number 1, you add the c point and write that if d is equal to 0, then roots are going to be real, okay, and equal. Done. So here we just saw that we have a quadratic expression for 4x square minus 12x plus 9, okay, whose discriminant is coming 0, okay. Discriminant is coming 0, that means it will have real and equal root, okay. That means that parabola will touch the x-axis at only 1 point, okay. Then if discriminant is 0, that means that parabola is, or that when you plot the quadratic equation, okay, expression, then that is going to touch the x-axis at a single point, okay. Here that point is 1.5 comma 0, and the root is 1.5, because for that value of x it's becoming 0, okay. Now let us see an example, okay, where discriminant is greater than 0, okay. So if I make a is equal to 1, okay, and b also 1, and c minus 6. Okay. So you can see this is the graph of this quadratic expression, 1x squared plus 1x minus 6. Okay. And you can see that this parabola intersects the x-axis, your x-axis, at 2 points. Okay. So the x-intercept, those x-intercepts are nothing but the roots of this quadratic expression. So here roots are 2 and minus 3. Okay, 2 and minus 3. And you can see that here discriminant is 25. Okay, so discriminant is 25. So obviously this is greater than 0 and it is a perfect square. Yes, it's a perfect square. So here you can see that d is greater than 0. So in our case it's 25. 25 greater than 0 and d is a perfect square. Square root of 25 is 5. So that's why roots are real. Okay, so here roots are coming minus 3 and 2. So it's real, rational, because I can write 3 minus 3 upon 1, 2 upon 1. So it's rational, and unequal. Both are different. Okay, so that means whenever discriminant is greater than 0, okay, in that case you can see that expression, quadratic expression, is going to intersect the x-axis at 2 points. Okay, so here and x-intercepts would be the root of that expression. Done. Okay, so this was an example where the d was greater than 0 and d is a perfect square. So that's why we got rational, real, and unequal roots. Okay, so see, unequal roots. Now let us take an example where discriminant is not a perfect square. Okay, so if, let me make this 2, I'm taking a new quadratic expression, minus 4, and here I make it minus 1. Okay, so I got this graph for this quadratic expression. Okay, so you can see it's a parabola. Yes, and here what do you observe, that this discriminant is 24. Okay, it's not a perfect square, it is greater than 0. Since it is a greater than 0, okay, this parabola intersect the x-axis at 2 points. One point is here, okay, this, and the other point is this. Okay, so here root is 2.22 and minus 0.22. okay, in fact they are irrational, but they have given up to 2 decimal places. Okay, so this is done. Now let us take an example of imaginary. Okay, let us take an example of quadratic expression, okay, equation where the roots are imaginary. Okay, so till now what we observed, that if d is equal to 0, okay, in that case the graph, okay, the parabola will touch the x-axis at 1 point. Okay, d0 means there are equal roots. Okay, there are equal roots. So in that case the parabola will touch the x-axis at 1 point. Okay, and if d is greater than 0, okay, if d is greater than 0, in that case parabola will intersect the x-axis at 2 point. Okay, and the x-intercepts of those points, okay, are going to be the roots. Done. Now let us see an example of a quadratic equation where the roots are imaginary. Okay, so here I'm taking a to be 1, okay, and b to be minus 4 and c to be plus 7. Okay, so here what you observe, that this graph, okay, this graph is not intersecting the x-axis anywhere. Okay, so whenever you see that graph is not intersecting the x-axis anywhere, in that case roots are going to be complex. Roots are going to be complex numbers. Okay, and these are the roots: 2 plus 1.73i and 2 minus 1.73i. Okay, can you see both are conjugate of each other? Yes, we had discussed this. Okay, if d is less than 0, okay, in that case roots are imaginary and they are going to be conjugate. So one is if one is 3.2i, then the other is, so here you could see that. Okay, like here you can see that this is the graph. Okay, it is not cutting, it is not intersecting the x-axis anywhere, so it has got imaginary roots, and imaginary roots are these: 2 plus 1.73i, okay, then other is 2 minus 1.73i. Done. So you should remember that quadratic equation, okay, graph means parabola. Okay, now let us proceed. Okay, now next we are going to discuss about the sum of the roots and product of the roots. So here whatever I'm going to explain, you don't have to write in your copy. Okay, just go through the explanation. Okay, so suppose I have a quadratic expression, okay, equation ax square plus bx plus c is equal to 0, where a is not equal to 0, and obviously by the formula one root will be this, okay, the other root is going to be this. Yes, now what I'm doing is I'm assuming this to be alpha and this to be beta. Okay, I'm denoting this root to be by alpha and this by beta. Now what I will do is I will take sum of these two, okay, alpha and beta. So alpha and beta, when I take sum, I get minus b upon a, okay, where b is the coefficient of x and a is the coefficient of x square. Next what I do is I take the product a alpha into beta and I get c upon a. Okay, so you have a quadratic equation, obviously we'll have two roots. Okay, and when you take the sum, okay, then you'll get minus b upon a, and when you take the product you will get c upon a. So here simply explanation is there, so no need to copy. You will write this one. Okay, you will write this: let alpha and beta be the roots of ax square plus bx plus c is equal to 0. A is not equal to 0, then sum of the roots is going to be minus b upon a. Okay, product of the root is going to be c upon a. Okay, now signs of the roots. Okay, signs of the roots. So positive roots, both roots will be positive if. So when we are going to get the roots to be positive, okay, so both the roots will be positive if minus b upon a, that means sum is positive and the product is positive. Okay, then only we'll get the positive roots. Okay, so let us see an example. Okay, if I take one quadratic expression, okay, whose a is 4, okay, and b is here, b is, let's say, 12 and c is 10. C is, okay, let's take this. C is equal to 3 and b is equal to minus 5 and a is equal to 2. Okay, a, let it be a. So here what you observe, that both the roots are positive. Okay, both the roots are positive. And why they are positive? Because we know that roots are going to be positive when minus b upon a is positive and c upon a is positive. Okay, so here we have taken such the same way. Here if I take minus b upon a, that means minus 5 upon 1. Okay, it's positive, and 3 upon 1 is positive. That's why see, roots are positive. Okay, so you should remember that by seeing the quadratic equation only, okay, you can tell whether the roots are going to be, both the roots are going to be positive or negative. Okay, Both the roots are going to be positive if minus b upon a is positive and c upon a is positive. Okay. And next, if you have to see whether both the roots are negative or not. In that case, if minus b upon a is negative and c upon a is positive, in that case both the roots are going to be negative. So let us see. So here we should have negative and positive. Okay, so negative and positive. Okay, so see this one. Both the roots are negative, and the reason is here minus b upon a is negative, okay, and c upon a is positive. Okay, that's why both the roots are negative. Yes, so both the roots are going to be negative, okay, if minus b upon a is negative and c upon a is positive. Next, roots of opposite signs. When we'll get roots of negative side, when the product of those roots is negative. Okay, when alpha and beta are negative, that means c and a have to be of opposite signs. So here my c is 3, okay, and a is 2. So if I make a minus 3, okay, so here you can see that you can see one root is here minus 0.44 and one is 3.44. Yes, both are of opposite signs. Yes. Next, roots are equal in magnitude but opposite in sign. When this will happen? When the roots are numerically equal but opposite in sign. When b is equal to 0. If b is equal to 0, in that case we will get that. Okay, so let's see. If I make b equal to 0, so you can check over here. One is minus 1.22, other is 1.22. Okay, so roots are numerically same, magnitude wise same, but sign wise opposite. Okay, so this is done. Okay, now next is formation of equation when roots are given to you. Okay, next topic is this. So here you have been given that alpha and beta are roots. Suppose there is one quadratic equation. Okay, and I don't know what is going to be a, I don't know what is going to be b, I don't know what is going to be c, but there is one quadratic equation, okay, whose roots are alpha and beta. So what you have to do, you have to find that quadratic equation. So how you will find that? This is the formula. So once you know those roots, then you can write the quadratic equation for that. Okay, that means you can write in ax squared plus bx plus c equal to 0 form. Okay, and this is how we are going to proceed. So firstly you have to write x squared minus alpha plus beta, where alpha and beta are the roots, into x plus alpha into beta equal to 0. When you evaluate this, okay, simplify it, then you will get in that form ax squared plus bx plus c is equal to 0. So that means if two roots are given for a quadratic equation, then you can write the expression quadratic equation. Okay, ax squared minus sum of the roots ax plus product of the roots equal to 0. Okay, now next here we are writing the quadratic expression ax squared plus bx plus c, okay, where x is real, is always positive. Okay, so suppose I have a quadratic expression. Okay, now in place of x I can put anything, like here if you see, here you can see this is your quadratic equation, okay, expression, minus 2x square plus 0x plus 3. So what I can do is, in place of x I can take any real value, yes or no? So once I put any real value over here, suppose I put 2 over here, then after calculation I'll get some value. Now it may happen that if I take x from here, okay, let's say if I take x from here minus 1, okay, then my answer will be positive, something over here, okay, because here, so in y-axis it is positive. But if I take x somewhere here, okay, then my answer will be negative, okay. So I may get negative or positive, okay. So but here what we are discussing is, if you have got a quadratic expression, okay, and if a is greater than 0 and discriminant is less than 0, okay, in that case your expression will be always positive, okay, no matter what value you put for the x, okay. And if a is less than 0 and d is less than 0, in that case that expression will output for the expression for any value of real x, you will get negative, okay. So let us see. So if I take a to be positive, let's say I took 2, okay, and b to be minus 6, and c if I take 5, okay. So what you observe over here, discriminant is less than 0, yes, and a is greater than 2, yes, a is greater than 0, okay, 2 is greater than 0, okay. So a is greater than 0, try to delete from here. A is greater than 0, in that case that means we have got 2 over here, 2 is greater than 0 and discriminant is less than 0, yes. So here 2 is greater than 0 and discriminant is less than 0. So you can see that no matter what value you take for x, okay, no matter what value you take for x, you'll always get positive value of this expression, yes. Can you see? If I take 1, then what will be for 1, its value is somewhere here, yes. If I take 2, then value will be somewhere here. If I take somewhere here 0 point something, then value will be here. If I take 2 point something, then value will be here. So you can see it's positive, okay, this expression will remain positive. Now when this expression will be negative, okay, if a is less than 0 and d is also less than 0. So let us take one example. If I take this to be minus 5, if I take b to be 15, okay, and c to be this has to be minus 7, okay, and b square okay. So if I take a to be minus 2, b to be minus 4 and c to be minus 3, so if I get a quadratic expression minus 2x square minus 4x minus 3, in that case we can see that this graph is coming below the x-axis, yes. So no matter what you put in place of x, this will output will be always negative, okay. So here you can see that a, that is minus 2, is less than 0 and discriminant is minus 8, that is less than 0. So that's why this expression is always negative. Done? Okay, so this is all about the explanation of this formula and this conditions and all, okay. In next video we will go through this exercise, okay. So this is all.